The Chengdu J-20 is a big deal. It's more than just another fighter jet. It represents a massive leap forward for China's military-industrial complex. For decades, the United States held a virtual monopoly on operational stealth aircraft. F-117 B-2 F-22, Raptor the J-20, nicknamed the Mighty Dragon, shatters that perception entirely. It is China's definitive statement that it has arrived as a top-tier aerospace power. This aircraft is not a copy. It is a purpose-built, highly advanced platform designed to contest air superiority with the very best. Its existence fundamentally alters the strategic calculations for any potential conflict in the Indo-Pacific. The significance of the J-20 extends far beyond its physical capabilities. Its presence in the PLADOF inventory sends a powerful geopolitical message. It signals that the technological dominance once enjoyed by the West is no longer absolute. The development and deployment demonstrate a level of sophistication, resource allocation, and national will that is impossible to ignore. For allies of the United States in the region, the J-20 is a tangible and proximate threat. Japan, South Korea, Australia. It forces these nations to reassess their own defense postures and invest in countermeasures and next-generation capabilities to maintain a credible deterrent. A metallic dragon whose shadow now looms large over the strategic chessboard of the 21st century. The story of the J-20 began long before its first public flight. Its origins trace back to the late 1990s under a highly classified program known as Project 718. This initiative was China's official effort to develop a fifth-generation fighter to counter the American F-22 Raptor, then the undisputed king of the skies. The PLADAF knew its existing fourth-generation fighters, even advanced types like the Su-27 and its derivatives, would be outmatched by stealth. The goal was ambitious: to leapfrog a generation of tech, produce a domestic aircraft to compete equally, a truly monumental undertaking. Development was shrouded in secrecy, managed by Chengdu Aerospace Corporation. Unlike Western programs that face public debate, the J-20's progress was a closely guarded state secret. The world got its first real glimpse in late 2010 when grainy photos leaked from a taxiway in Chengdu. Those images stunned the global defense community. Many analysts, including US intelligence, hadn't expected China to produce a stealth prototype so quickly. The official unveiling came on January 11, 2011, when the J-20 performed its maiden flight, a deliberate signal to the world. The timeline from first flight to operational service was remarkably swift for such a complex aircraft. After the 2011 debut, a series of evolving prototypes appeared, each with refinements from testing. Later, airframes showed changes to the air intakes, canopy, sensor placements, signaling a rapid iterative development. By 2016, low-rate initial production models were delivered to the PLADAF for testing and evaluation. This phase was crucial for developing tactics, training pilots, and integrating the fighter into command and control, a process far more complex than just building the plane. In March 2017, Chinese state media announced the J-20 had entered PLADAF service. That marked a historic milestone for China's armed forces. It meant China had moved from concept to operational stealth fighter in under 2 decades. Since then, production has ramped up with newer, more advanced variants emerging. Project 718's journey shows China's focused investment, technological ambition, and its ability to rapidly turn strategy into capability, changing the face of modern air power in the process. The J-20's appearance is striking. It immediately sets the J-20 apart. Side-by-side comparison of J-20 with F-22 and Russian fighters, from its American counterparts, and from its Russian counterparts. Wind tunnel footage and CAD model of J-20 shape analysis. Its design blends optimized features, low observability, stealth, high-speed aerodynamic performance, long sweeping side view of J-20 showing fuselage length. Most prominent is the long, wide fuselage. It blends the wings and blends the body smoothly. Radar cross-section animation showing wave deflection. That reduces radar cross-section. The airframe uses chiseled lines and aligned edges. Those shapes deflect radar waves away from the source. Close-up of J-20's diverterless supersonic inlet with airflow simulation. A key feature is the diverterless supersonic inlet, the DSI. These bumps manage airflow into the engines at supersonic speeds. Comparison of mechanical intake ramps on F-15 and Su-27. They do it without heavy mechanical ramps. Older fighters with ramps, like the F-15 or the Su-27. J-20 high-speed flight with visible shock effects. The DSI improves performance, and it cuts the frontal radar return. Single-piece bubble canopy with pilot visibility demonstration. The canopy is a single-piece bubble. It gives the pilot excellent visibility and removes the radar reflective two-piece framework. Close-up of landing gear doors and access panels with sawtooth edges. Even small details, landing gear doors and access panels, use sawtooth edges to scatter radar. Front-on view of J-20 showing canards with close-up of movement. The canards, small wings near the nose, are the most debated element. Fighter performing high-angle maneuver with canards deployed. Canards provide enhanced maneuverability, especially at high angles of attack and at low speeds. Radar reflection animation from moving canard surfaces. But canards can hurt stealth. Movement creates radar reflections. Engineers inspecting J-20 with design team around model. Chengdu appears to have made a deliberate trade-off. They prioritized aerodynamic performance, stealth coding application and flight control software animation, likely mitigating the stealth penalty with advanced materials and precise control laws that limit movement in high-threat environments. Split screen of J-20 maneuver versus stealth silhouette. That hints at a philosophy balancing stealth with kinematic prowess. Unlike the F-22, which prioritized all-aspect stealth, overhead shot of J-20 delta wing and all-moving vertical tails, the J-20 layout uses a delta wing and all-moving vertical tails. That layout is optimized for sustained high-speed flight. Fuselage cutaway showing internal fuel and weapons bay space. The long fuselage gives internal volume for fuel and for weapons, crucial for a long-range interceptor. J-20 flying over open ocean representing power projection capability. It's a design born to project power far from China's shores, and to hold high-value enemy assets at risk. The true lethality of a modern fighter lies not just in its airframe, but in its electronic nervous system, its avionics, sensors, the weapons it carries. The J-20 is packed with a suite of highly advanced systems that make it a formidable opponent. At the heart of its sensors, the large AESA radar, believed to be the Type 1475. AESA versus mechanical, tracks multiple targets in different directions simultaneously, far more resistant to jamming. Result, superior situational awareness for the pilot. That situational awareness lets the pilot detect, track and engage enemy aircraft from extended ranges long before the J-20 is detected. Beyond radar, the Distributed Aperture System, or DAS, 6 infrared sensors placed around the airframe gives a full 360-degree spherical view. DAS can detect the heat signature of incoming missiles, spot enemy aircraft from any angle, and provide imagery for navigation in low visibility. Electro-optical targeting system under the nose acts like a stealthy long-range sniper scope, enables passive targeting without emitting radar. To keep stealth, primary armament is carried internally. Large main weapons bay under the fuselage capable of holding at least 4 long-range air-to-air missiles, such as the PL-15. PL-15 reportedly exceeding 200 kilometers range, featuring a dual-pulse rocket motor that keeps it energetic late in flight, giving the J-20 a significant long stick to outrange many Western missiles. For closer encounters, 2 smaller side bays, each housing a single short-range, high-off-bore sight missile like the PL-10. The pilot's interface is a state-of-the-art glass cockpit, large single-piece panoramic touchscreen display, wide-angle holographic head-up display, sophisticated helmet-mounted display projecting information onto the visor, allowing the pilot to simply look at a target to lock onto it. This fusion of advanced sensors, potent long-range weaponry, and an intuitive pilot interface makes the J-20 not just a stealthy airframe but a truly integrated and lethal weapon system designed for the information-rich battlefield of the 21st century. For all its impressive advancements in stealth, avionics, and aerodynamics, the J-20 program has been persistently hampered by one critical area: high-performance jet engines. Developing a reliable, powerful, and durable engine is arguably the most difficult aspect of creating a modern fighter, and China has struggled for decades to master this technology. Early J-20 prototypes and initial production batches were powered by Russian-made Saturn AL-31F engines, the same power plants used on the Su-27 flanker family. While capable, these engines were really just a stopgap measure. They lacked the thrust and thermal efficiency needed to unlock the J-20's full kinematic potential, particularly its ability to supercruise, basically to fly at supersonic speeds without using fuel-guzzling afterburners. China's domestic engine development efforts have been focused on the Shenyang WS-10 Taihang engine. Later batches of the J-20 were fitted with an improved variant, likely the WS-10C. This marked a significant step forward as it began to wean the program off its reliance on Russian hardware. The WS-10C offers more thrust than the AL-31F and features serrated sawtooth nozzles to help reduce the aircraft's rear aspect radar and infrared signature. However, even this improved domestic engine is widely believed to fall short of the performance offered by the Pratt & Whitney F119 engine that powers the F-22 Raptor. It's a good engine, but not yet a world-class one. The ultimate goal for the J-20 has always been the indigenous Shenyang WS-15 engine. This is a far more ambitious design, intended to be a true fifth-generation power plant. The WS-15 is designed to provide the massive thrust needed for sustained supercruise and high-G maneuvering, finally allowing the J-20 airframe to perform as its designers intended. However, the WS-15 program has been plagued by years of delays, reportedly facing significant challenges with reliability, metallurgy, and achieving the required time between overhauls. These are common but formidable hurdles in advanced jet engine development, where components must withstand extreme temperatures and pressures. As of today, the WS-15 is finally starting to be integrated into new-build J-20s, with reports of test flights and initial production becoming more common. Once this engine is widely fielded and proven reliable, it will resolve the J-20's most significant weakness. A WS-15-powered J-20 would be a far more formidable aircraft with superior acceleration, climb rate, and the crucial ability to supercruise. This would allow it to control the engagement envelope, dictating when and where a fight occurs, and to chase down or escape from adversaries more effectively. The engine has long been the J-20's Achilles heel, but it appears China is on the cusp of finally solving this critical puzzle. When discussing the J-20, the inevitable comparison is with America's premier stealth fighters, F-22 Raptor, F-35 Lightning II, J-20 Mighty Dragon. The F-22 is the benchmark for air superiority. It's widely considered the most capable air-to-air fighter ever built. The F-22 blends extreme stealth, supercruise, high maneuverability, and advanced sensors. In a hypothetical one-on-one dogfight, a mature WS-15-powered J-20 would still face a formidable challenge. The F-22's all-aspect stealth is believed to be superior to the J-20AS, particularly from the sides and rear. The J-20 is a larger aircraft. It has potentially greater internal fuel capacity, and with its PL-15 missiles, it may possess a longer engagement range. The J-20's design philosophy appears to differ from the F-22S. While the Raptor was built to be the ultimate air dominance fighter, the J-20 seems tailored more as a long-range interceptor. Its job is to penetrate enemy defenses and eliminate key assets like tankers and AWACS. The comparison with the F-35 is more complex. The F-35 is not a pure air superiority fighter like the F-22. It's a multi-role jack of all trades. Its greatest strength is sensor fusion and networking, acting as a flying quarterback that gathers and shares data across the battlefield. Its stealth is highly advanced, but it lacks the raw speed and kinematic performance of the F-22, or a mature J-20. In a beyond visual range engagement, the F-35's superior situational awareness and networking could give it a crucial edge. However, if the fight gets closer, the J-20's potential advantages in speed and maneuverability could put the F-35 at a disadvantage. Ultimately, combat between these aircraft would not happen in a vacuum. It would involve a complex web of supporting assets: ground-based radars, satellites, electronic warfare aircraft, and drones. The J-20 was designed specifically to operate within the PL-8AF's integrated air defense system. While the F-22 may be the better individual fighter, China can produce J-20S in far greater numbers. The F-22 production line has been closed for over a decade. The sheer quantity of J-20S, combined with their advanced capabilities, could potentially overwhelm a smaller force of F-22S. The J-20 doesn't have to be better than the F-22 in every respect. It just has to be good enough to change the outcome of a conflict. Another crucial comparison for the J-20 is with Russia's fifth-generation Sukhoi Su-57 codenamed Felon by NATO. They represent two very different approaches. J-20 Huawei, frontal aspect stealth, J-20 high-speed interception, Su-57, extreme supermaneuverability, Su-57, raw speed, Su-57, powerful sensor suite, but it makes compromises in all aspect low observability. The Su-57 is a beast of a machine, built for raw kinematic performance, capable of incredible agility. thanks to three-dimensional thrust vectoring nozzles, and its advanced aerodynamic design. From a stealth perspective, the J-20 appears to hold a significant advantage. The Su-57 has exposed engine fan faces, and a less meticulously shaped airframe compared to the J-20 or F-22. That makes it likelier to be easier to detect on radar from certain angles. Russia may prioritize breaking the kill chain through powerful electronic warfare systems, and extreme maneuverability to defeat incoming missiles. The J-20, in contrast, follows a stealth-first philosophy. Su-57, cheek-mounted side-looking radars, Su-57, L-band radars in the wing leading edges. Those systems might help detect stealth at closer ranges, but the maturity and integration of those systems is debated. The J-20's DAS. The J-20's large ESA radar, appearing more mature and integrated. Both aircraft can carry powerful long-range missiles. Su-57 fields the R-37M, J-20 carries the PL-15. That makes beyond visual range combat between them especially dangerous. The biggest difference is industrial scale. China is mass-producing the J-20. Well over 200 airframes are already in service. Production is ramping up with more advanced variants. In stark contrast, the Su-57 program has been plagued by delays, funding issues, and very slow production rates. The number of operational Su-57s remains extremely small, so while a one-on-one theoretical matchup is interesting, the strategic reality is the J-20 is a mature, mass-produced system, while the Su-57 is still struggling to become a major component of Russia's fleet. The Dragon has already taken flight in large numbers, while the Felon is still finding its footing. The Chengdu J-20 is not just a trophy piece, it's a critical tool designed to execute specific missions within China's broader military strategy. Its primary role is to serve as the sharp point of the spear, enabling the PLADF to gain and maintain air superiority. In a conflict over the Western Pacific, it uses stealth to slip past integrated air defense systems and outer fighter screens. Once inside that defensive bubble, its mission is to hunt down and destroy high-value assets, AWACS aircraft, tankers, ISR platforms. By taking out these force multipliers, the J-20 can blind and cripple an opposing air force. Without AWACS for command and control, fighters lose situational awareness. Without tankers, fighters lose operational reach. Fighters like the F-25 and F/A-18 become far less effective. This is the anti-access/area denial strategy, A2AD. The J-20 is the airborne spearhead of that strategy. It can create a contested bubble over the Taiwan Strait, or over the South China Sea. Its mix of stealth, speed, and long-range PL-15 missiles suits long-range interdiction. It's also a premier air-to-air fighter, tasked with clearing opposing stealth aircraft like the F-22 and the F-35. It operates with ground-based radars, satellites, and other airborne sensors. China is investing in multi-static and low-frequency radar systems to better detect low-observable aircraft. The J-20 can take off-board targeting cues, stay electronically silent, and close in for the kill without using its own radar. Looking ahead, the platform will evolve significantly. The two-seat J-20S is already emerging. The backseater likely acts as a mission commander, or as a drone controller managing swarms of loyal wingmen. The J-20 becomes a command node for autonomous systems. Future upgrades, more powerful engines, enhanced sensors, next-generation weaponry, more advanced stealth coatings, ensuring the Mighty Dragon remains a formidable vanguard for decades to come. The arrival of the Chengdu J-20 has permanently altered the landscape of global air power. For the first time since the dawn of the stealth age, the United States and its allies face a peer competitor who can field a low-observable fighter in significant numbers. This dismantles the assumption of automatic air superiority that underpinned Western planning for over 30 years. The J-20 is not a future threat. It's a present-day reality forcing a rethink of air combat doctrine, technology investment, strategic priorities. Its existence has injected new competition and urgency into military aviation. The J-20's impact is most profound in the Indo-Pacific. It gives China a credible tool to enforce its A2/AD strategy. It challenges the U.S. Navy's ability to operate near China's periphery. It challenges the U.S. Air Force's ability to operate near China's periphery. The strategic balance in the region has shifted. Japan, Australia, South Korea, all F-35 operators now face an adversary that can mirror, and sometimes exceed, their capabilities. This has accelerated modernization efforts and tightened defense cooperation with the United States, creating a more tense, heavily armed region where the margin for error is shrinking rapidly. From a technological standpoint, the J-20 is a powerful driver of innovation. The US is pushing its secretive NGAD program to develop a sixth-generation fighter to leapfrog the J-20. The need to detect stealthy platforms is fueling investment in new sensor technologies. The need to track them is driving networked warfare concepts. The need to engage them is accelerating directed energy weapons. The J-20 has reignited great power aerospace competition. Every Chinese advancement will prompt a Western countermove, and vice versa. In summary, the Chengdu J-20 is far more than just a fighter jet. It's a symbol of China's rise. It's a potent military instrument reshaping strategy. It's a catalyst for new technological competition. Its long, chiseled frame casts a shadow over the Pacific. The era of uncontested American air dominance is over. The skies are now a contested domain, and the Mighty Dragon is one of the primary reasons why. How the world adapts to this new reality will define the future of air combat and international security for decades to come.